Information hiding is also an emerging research area, such as copyright protection for digital media, watermarking, fingerprinting, steganography, and so on and so forth, which are used to conceal or protect sensitive and confidential information. Steganography is a technique that prevents unauthorized users to have access to the important data. See, steganography and digital watermarking provide methods that user can hide and mix their information within other information that make them difficult to recognize by attackers. Image steganography is the process of hiding information which can be text, image, or video inside a cover image. The secret information is hidden in the way that is not visible to the human eye. The main goal of information tech hiding is to prevent unauthorized access or detection of sensitive data. By hiding information, individuals or organizations can safeguard their data from being compromised or accessed by the third parties. Information hiding technique ensures that one concealed data is only accessible to those with proper authorization and knowledge. With this prelude, today I hope a case study will be discussed by the eminent panelists who are really a pillar in the area, in the field of discussion. I hope today's webinar will be enjoyed by all the participants and will be able to gather a good knowledge from this webinar. In fact, I am also having a background of electronics, telecommunication, and computers, so I will be enjoying this program, and I would like to get a lot of good information what Mr. Mukherjee and Ms. Dhali is going to contribute. Thank you and welcome you once again, sir.
I welcome all the participants from my side, and here is a small description of our today's webinar. Our chairman has already explained what is image processing. Why it is done? It is done to enhance an existing image or to sift out important information from it. Image is a versatile media that is attractive to all. I do not know my microphone is on or not. Just a second.
It's audible, no problem.
Okay.
It's okay. It's okay.
Just a sec. I go back. In the current generation, images are used for several vulnerable purposes. Information hiding is an emerging research area whose general concept encompasses various techniques and methodologies such as copyright protection for digital media, watermarking, fingerprinting, steganography, etc., which are used to conceal or protect sensitive or confidential information. The main goal of information hiding is to prevent unauthorized access or detection of sensitive data. By hiding information, individuals or organizations can safeguard their data from being compromised or accessed by unauthorized parties. Information hiding techniques ensure that the concealed data is only accessible to those with proper authorization or knowledge. Due to improvements in network activities, information hiding techniques are recently gaining and increasing attention from actors like cyber criminals, terrorists, and state-sponsored groups, as they allow to store data or to cloak communication in a way that is not easily discoverable. Multiple methods of information hiding can be used by criminals to conceal incriminating data. Steganography is a technique. Just a sec. Sorry. Steganography is a technique used to conceal the existence of secret information within innocuous carriers such as images, audio files, or text documents. Due to the versatile acceptance of digital images, this medium is very much usable for information hiding steganography. These techniques aim to ensure that the hidden data remains undetectable to anyone who is not the intended recipient. Steganography is often used in combination with encryption to provide an additional layer of security. By encrypting the hidden information before embedding it within the carrier, even if the steganographic content is discovered, it remains unreadable without the decryption key. While steganography has legitimate uses, such as covert communication or digital watermarking for copyright protection, it can also be employed for malicious purposes, such as hiding malware or facilitating covert operations. CDAC Kolkata team is working for prevention of malicious use of steganography. The team has come out with two products in this lecture session. The basics of information hiding and steganography, along with the real case study, will be discussed. In addition, the state of their steganalysis technique will be talked about. This is a brief introduction of the topic that will be discussed today. Shudip, any of the VVIPs are here other than our chairman?
Sir?
Any of the VVIPs are there? I think Mr. Mundada is not there, Mr. Chairman is not there. So should I go to introduce our panelist and moderator?
Yes, sir. Yes, sir.
Okay, okay. Thank you. Just a sec. First speaker will be Madam Sonali Dhali Mustafi.
Madam Dekhani.
Huh?
No, you carry on.
Okay. She is Joint Director CDAC Kolkata. She has 17 years of industrial experience in the areas of image processing, steganography, steganalysis, pattern recognition, and computer vision. Her expertise in software development in file format analysis, image, video, audio, etc., steganography and steganalysis, computational genomics, HPC, etc. She has completed her MCA from IIST, Bengal Engineering College, Shivpur formerly, and BSc in Mathematics honors from Lady Devon College. We have another panelist, Mr. Ritesh Mukherjee. He is Associate Director CDAC Kolkata. And he is an MTech in software engineering. He is associated with IT industry for more than 20 years. Software solution development is his profession as well as passion. The maximum period of his tenure is spent on developing commercial product solutions. A few success stories are as follows: successfully implemented more than 10 projects, published 1 US patent, 1 Indian patent, 3 copyright, more than 8 journal papers, and a few national international conference papers. He bagged 2 international awards, 4 national awards, including prestigious CDAC DG R&D award. He is one of the associate directors of CDAC and took charge of Group 8 ASPG Advanced Signal Processing Group from 1st June 2022. He is completed a year in that. His main area of interest is handling large databases and developing solutions for warehousing, data mining, big data analytics, etc. And his objective is to take lab prototypes to the field. His most recent achievement in that direction is a successful implementation of a homegrown solution around the face recognition engine for SCRB, which is formally launched by the Honorable CM of Tamil Nadu. Since the launch of the solution, the police officers of the state of Tamil Nadu are using the solution and are able to know the criminal antecedents of 65 suspects, around 600 accused and 480 passports, as well as other police verification applicants. A very good application indeed. We have our moderator, our very dear and very own Chantal Chakraborty. He is PE MBA, have more than 35 years of professional experience in telecom and IT. He worked with companies like CSP, NTPC, DOT, and BSNL, and worked as Chief Technology Officer and Vice President in Aircel, Uninor, and Reliance Jio. He has wide experience in planning, design, procurement, installation, and maintenance in all fields of telecom. Currently, he is working as CEO and Executive Director of ATM Towers India Private Limited, a subsidiary of a Denmark-based company, ATM AS. He participated in several national and international seminars, including GSM Congress at Cannes, France, and Berg for international roaming. He has received different accolades, including Vishish Sanchar Seva Award from the Ministry of Communication, professionally associated with IEI India and ISA USA. He is the secretary of ISA Kolkata section as well. He is a team member a team player and loves to serve society and to the best of his ability. Over to Chanchal to conduct the webinar this evening. It is our 20th webinar from ET Division with Guru State Center IEI.
Thank you,
Chanchal, over to
Ramda.
you.
Thank you, Ramda. Thank you, Dr. Das. And thanks to our eminent speakers. Today, we invite our speakers, Mr. Ritesh Mukherjee and Sonali Dhali Mustafi, for giving the presentation on the path-breaking session on image processing information hiding using steganography as case study. Over to Mr. Mukherjee and Madam Sonali Dhali Mustafi. Over to you. The stage is yours.
Okay. Yeah. Good afternoon. Am I audible?
Yeah. Good afternoon.
Thank you all. I mean, I should thank Chonchal sir for giving me this opportunity to share our experience in the area of image processing, computer vision, and whatever activities presently we are pursuing. So, I can see total number of attendee is 10 only, and panelist is 6. So, should I wait for some time or start the session right now?
I think you have to start.
Okay.
Let them join as and when they come.
Okay. Since the number of attendees is pretty low, so I would request all of you to make the session interactive, because image processing is a vast subject, and in the name of our group is Advanced Signal Processing Group. So in our group we used to do image processing, video signal processing, at the same time speech signal processing also. At this in this session, basically we will cover image processing, where we will show you one of the case studies, steganography, and basically steganolysis, the reverse part of it. So it's a huge subject. I will try to make it convenient for you, because I know the audience is heterogeneous in nature. Still, if you have any doubt at any point of time, I would request you to stop me at that point of time and ask the question, such that I can try to make it understandable to you as per my knowledge, right? So I need not to say about CDAC. You must be knowing what is CDAC, Center for Development of Advanced Computing. Most of you must be knowing CDAC for supercomputer forum, the inventor of supercomputer. So in CDAC, we have our presence at almost in 12 states, and CDAC used to do the supercomputing activities. Not only that, electronics related activities and software development activities as well. In Calcutta Center, we have 4 groups. Out of that, one of the group is Advanced Signal Processing Group. As I already told you, total team strength of Advanced Signal Processing Group is around 32. So our activity is confined within the periphery of Advanced Signal Processing. It is related to signal processing only. So in the very beginning, I will start with this image processing and computer vision. As one of the panelists already told you, that image processing is related to processing image for enhancing the image quality. Yes, it is true. But in this session, we are not covering that part. Simply, we'll try to present image processing from computer vision point of view. So what is, let me make it just for a moment. Well, so what is computer vision? It is clear from the picture itself. Computer is seeing something. Say, for example, a human being can sense something, can see something. But in this case, we are trying to make the same kind of thing, trying to mimic the same thing on computer, and computer will be able to understand whatever is visible in front of it. So obviously, one sensor should be there. This webcam or any kind of camera is there. Camera is taking the picture, and computer is processing the same thing to make it understandable and making it to understandable to the entire system in the back end. So in human vision, you can see one scene is in front of your eye, and you have seen the scene that is processed through your neural network, and finally you are classifying it as some object, and your system is doing something depending on whatever you are seeing, right? So that is the action you are taking. In computer vision, we will try to mimic the same action, and you can see below there is something already. One picture is available, right? Which is called deep learning or something I have written. So what is deep learning? That I will explain during my session. So this is the formal definition of deep learning. Artificial intelligence, any technique that enables computer to mimic human behavior is artificial intelligence. Well, a subset of that is machine learning. That is the ability to learn without explicitly being programmed. And deep learning is again the subset of that, which will extract the pattern from data using neural network. One blind person, you can see one blind person can easily recognize whatever is there in front of him with his stick. So how he is doing that? Simply with his stick, basically is trying to understand the shape of the objects or some other sound or something from the object. Based on that, they are classifying it and they are behaving like that. So computer is also doing a similar kind of thing. It is trying to extract the pattern. So based on the pattern, you will act accordingly, depending on the program, whatever is written in the backend. So computer vision algorithm lies between machine learning and deep learning nowadays. Face detection, you can see one of the algorithm is Viola-Jones. This is face detection algorithm. Everybody is using it every day. From your mobile camera also you will be able to see this type of facial image will be cropped or somehow marked with one green color, green border or something. That is nothing but facial detection. And second part is face recognition. As in my introduction, someone in the panelist said that already we implemented one solution around face recognition solution. Yes, it's a good solution. We implemented it for the state of Tamil Nadu, and all the police people are using it. Basic intention is the police person who is, if somehow the police person saw a suspicious person, in that case, the police person can take the snap of that person, facial image of that person, and try to search it from their database. Basic intention is to find if there is any criminal antecedent against that person, right? So it's a useful application. Similar kind of application you must be knowing. One is DigiJatra application, right? In DigiJatra application, you will see you can enter into the airport without any delay in any point of time. So that is another one application around face recognition. But whatever you are seeing, face recognition or face detection, those are nothing but some sort of application around image processing and computer vision only. Well, so coming to this point, what is computer vision? It is nothing but machine sees the image as a number, right? Because machine can process only 0 and 1. So whenever one RGB image is appearing in front of the computer, it is, for computer, it is basically nothing but 3 layers. One is red layer, one is green layer, another one is blue layer. Similarly, for grayscale, this is only single layer. And this layer consists of one matrix. And that matrix looks like this. So matrix consists of the pixels. You can see here in the grayscale image, you can see it's a 4x4 matrix. That means 4 pixel by 4 pixel. And everywhere you can see some value is there, written over there, right? So if the value of the pixel is 255, that means it is white. If the pixel value is 0, in that case, it is black. Similarly, any value between 0 to 255 will be reflected accordingly, right? Similarly, for RGB image, you can see one R layer is there, that is for red. One G layer is there, that is for green, and another B is for blue. So, but the values are almost like grayscale image, as I already explained. Similar kind of values are there, but computer used to interpret any image, maybe RGB or maybe grayscale, in pixel values. That is basically in matrix. So what action computer can take? Nothing. Computer can make some sort of classification. Basically, computer would like to understand what is appearing in front of it. So classification is a task of assigning an input image one level from the fixed set of categories. So at present, I can see one presentation in front of me. So my brain is already programmed to understand this is a presentation going on. Similarly, if I can do something in the computer, which will try to understand what is happening and what is appearing in front of it. See, this is an example, pictorial example. Input image, as I said, if it's a grayscale image, in that case, it will be reflected as a matrix only. Now, you are classifying it. What exactly you are doing? You are classifying it to understand what is appearing in front of you. So the probability of this image become a cycle is 0.05. For bus, it is 0.10. For car, it is 0.80. And scooter is 0.05. So you can see the maximum probability for this image as per computer program is 0.80, which is nothing but a car. So in that way, computer try to understand what is appearing in front of it, right? So how we can do this? Some specific characteristics are unique in car image, right? So basically, we'll try to find out the characteristics which is unique for that car. Based on that, we can do that. And classification is done by detecting those characteristics or features. In computer vision, those are called as features only. So if some specific feature which is supposed to be present in a particular level and that is really available in the picture in front of you, in that case, computer will classify as that object, whatever is appearing in front of it is nothing but that particular object where this feature is supposed to be there. But how we can do this? Manual feature selection, in case of manual feature selection, you can see in the left part, what is there? One X is written, right? In white, one X is written. And in the right side, it is something which is almost like X, but it is not exactly X. So you can think it in this way. In the left side, it is a standard template of X. That means it is printed X maybe. In the right side, it is not standard. It is little bit deviation from the exact X. So that is handwritten character. But human being can easily identify left side as X, right side is also as X. But if I really program a computer to understand whether the image is X or not, in that case, it will do what? Simply, it will reject the right side image and accept the left side image. But instead of that, if we can put some sort of probability based on the features which is supposed to be available in X, in that case, probably we will get the correct information. That means the probability will be high, and in that way, we can say the right side image is also X. So what kind of feature we will see in this image? You can see these are the unique features of X, right? 1 2 cross 2 matrix with 1 minus 1 minus 1 1, something like this. So this is expected in any X, total 5 features should be there. 4 2 cross 2 matrix and 1 3 cross 3 matrix, right? Now, if I try to find the same thing in the right side image, what will happen? We will find all those features, whatever already we identified as unique features of X in the right side image also. Only thing is, those features are not available in the exact location where we are expecting it. It is little bit deviation from the exact location. So we have to check whether those features are available in the image or not, whether those features are available in the image in right position or not. If it is not in the right position, in that case, whether it is acceptable deviation or not, right? So feature extraction programmatically, how we can do some sort of feature extraction? We can do that using convolution. In convolution, various filters are scanned through all over the image to trace out the features present within the raw image. And it's basically done in raw measure order. That means, say for example, this is one feature set on the left top part. You can see one feature set is there. You can simply try to match the same feature within the image. In that case, what you have to do? You can slide it in left, in row measure order from the left side to the left top to right bottom. So it was by determining the value of central pixel by adding the weighted value of all its neighbor together. I'll give you an example. It is pictorial example which will help us to understand in a better way. So what is convolution operation? One image. On top of that, we are applying one filter or kernel. Which way? This is the pictorial representation of the same thing. Say, for example, this filter. Simply, if we try to match it on the left top portion, 3x3 matrix, and we will get some value. What is that value? How we will get that? I'm coming to that point. But simply try to understand one image is there. Image means from computer point of view, it is a matrix. One matrix is here. And that matrix consists of the pixel values. Now I am applying one filter. Filter matrix is much, size is much less than the actual image. And we are applying it in row measure order, trying to identify whether that particular feature is available in the image or not. So we are applying this, and the terminology is convolution. We are applying filter, doing convolution, and getting some result. So similarly, we can apply the same thing in this way, row measure order and in sliding window mode, right? So one by one, we can traverse and we can try to find out the exact value. Fine. Now, how we'll get that value and what is that value? What is convolution operation itself? So you can see this is nothing but one matrix multiplication. When we are trying to apply convolution in a particular area, in that case, it is nothing but a 3x3 matrix, and the filter we are going to apply, that is also 3x3 matrix. So convolution means nothing. We are doing matrix multiplication, and matrix multiplication means this one will be multiplied with this one, -1 with -1, -1 with this -1, and so forth, so on and so forth. You will get one value. Say, for example, 6. That means whenever I am applying this filter in this zone, the result will be 6, and we are putting it here. So what is this 6? I'm coming to that point. But basically, whenever you are trying to understand whether one particular feature is available in the image or not, you will try to apply one filter from row measure order, trying to identify that feature is available or not based on the value which we are getting through matrix multiplication, right? So effectively, whatever we are getting, that is called feature map. Feature map will give you the reflection that whether the unique feature identified by you for a particular object is available in the image or not. So now the second part, convolution kernel, different kind of convolution kernels are available. And these convolution kernels are already available for different operations. Say, for example, if this image is very popular, amongst the image processing people, Lena. Most of the papers of image processing, you will find this image. So if we apply one filter like this, 0, -1, 0, -1, 5, -1, 0, -1, 0, in that case, it will sharpen the image. Similarly, for edge detection, we can apply this filter. For strong edge detection, we can apply this type of filter. So different kind of filters we can apply on any image for different purposes. As one of the panelists already said, we can improve the image quality. For improving the image quality, this is one of the technique applying which you can improve the image quality as well. But our intention here is to understand whether, basically we would like to classify the object which is appearing in front of us. For that purpose, we have to understand whether the unique features already identified by us is available there or not. Now, what are the features, how we can identify those features, and who will give us those features, right? You can see these are the manual features and the drawback on manual feature extraction also. You can see for any kind of feature, you have to have some domain knowledge. Otherwise, you will not be able to know. Second part is you have to define the features in your own way. That means your system is already trained with those features. Your system at least have one dictionary or something which will give them the clear idea about what are the features they have to check in the visible image in front of it. Next one is detect the features to classify. Now you have to identify the features, try to understand the probability of it, and in that way you will try to detect the features which will help you to classify the object. But different drawbacks are like viewpoint variation. On the left bottom corner you can see the same image, it is tilted, or it is rotated by 90 degree. In that case, how computer system will try to identify the features, unique features, because you have to apply the filter accordingly. You cannot apply the filter as it is. So that is one of the major drawback. Second one is scale variation. You can see both the objects are basically human being, but one is pretty short height and second one is in standard height. So in that case, the scale variation is also there. If we try to apply the filter, in that case, you have to define the filter accordingly such that you can accommodate the scale variation in your algorithm, right? Next one is deformation. You can see clear deformation is visible. So if deformation is there, still you have to identify whether it is the same person or not, same object or not. In face recognition solution, whatever we implemented for Tamil Nadu, there is one option for identifying this, recognizing dead bodies, because this is one of the requirement of the police people. Whenever they are finding any unidentified dead bodies, they used to take the snap facial image of that person and try to match it with any missing diary or any FIR or any other record which is available with them. So in that case, most of the situation, whatever dead body, unidentified dead body they could find out, deformation is there. So somehow we have to design our algorithm accordingly, which will able to cater this deformation as well. Now occlusion, you can see this cat is not visible properly because only the facial part of the cat is visible. So partial occlusion or complete occlusion, this is one of the obvious feature which we have to somehow manage. During COVID period, most of the cases, the facial recognition was very difficult because of this mask, right? Now, left bottom corner, you can see illumination condition. Lighting condition may vary. So your algorithm should be robust enough to accommodate this illumination conditions also. Background clutter, you can see that if the background clutter is there in the image, in that case also you have to try to find out the available features for classifying that object itself. Now coming to intra-class variation. Whatever image is there in the right bottom corner, all are of chairs, right? But the chairs itself by design are of different type. So images of chairs may vary. So your database, wherever you are preserving the existing images, in that case, it should be sufficient to accommodate all variations of interclass and interclass variations. So that is also not very easy. So these are the manual feature extraction and some drawbacks over there. But those were obvious in image processing and computer vision earlier. Now after incorporation of neural network or deep learning, we can get rid of this feature, these things easily, comparatively easily. How? We can use neural network based approaches to learn these visual features directly from the image. So you need not to put those features in your dictionary or in your database. Features will be learned by the system automatically. Say one blind person, we know this is a step or this is a chair, this is a table, right? So we can see it, we have one mental map. Based on that, we can understand this is a chair or table or something. But one blind person who is blind from the birth, so they don't have any that kind of understanding of images like a chair or table or something. But they can easily recognize one chair or table based on some perception. How? So through stick, probably they try to measure the length or breadth or some mechanism is there. Based on that, they have one feature set which already they developed, and based on that feature set, they easily classify the objects whichever is appearing in front of it. Similar way, in case of neural network based approaches, you need not to define the features for learning the system. Rather, computer itself will learn those features. What are the features which is suitable for a particular, which is unique for a particular object, which is which should not be there in the object if it is not belongs to that class. So we can also develop a hierarchy of extracted features to represent an image internally to the neural network. So you can see, I have already mentioned this is neural network. So what is neural networks? Just like our human neural network, this is nothing but a network where all the these nodes are called perceptron. Actually, in our case, it's called neuron. In human being, it's called neuron. The similar thing in computer system, it's called perceptron. Perceptron, think in a easy way. Perceptron is nothing but one function, say for example, which can accept more than one value, process it, and after processing, it will simply supply the output to the next layer. So what we can do, we can develop one network where the features, different kind of features can be extracted at different layers, and those layers are somehow connected. At the end, we will get something in the output layer. But output layer will do what? Basically, in output layer, it will classify the object based on its learning. Neural and deep neural network, how it works and what is the basic differences. One slide for it. Neural networks are inspired by the working of human brain, as I already told you. So, you know, the inputs are there. In the first layer, this is input layer. Input layer is processing the inputs. What kind of processing it can do? Say, for example, as I said, one image, whenever one image is coming from the camera or something, in that case, it may do some sort of cropping or some sort of normalization or something. So that is the activity of the input layer. Now, in between, there is one hidden layer. Hidden layer is doing something for the sake of simplicity. Let us assume this hidden layer is taking the decision based on the input, and some sort of mechanism is already developed. Now, in the output layer, what it will do, in the output layer, simply one of the node will be activated based on the result of the hidden layer. So what is the intention of that? The node which will be activated, that is basically the classification of that object, right? One image is there for your better understanding. Well, a neural network with multiple hidden layers and multiple nodes in each hidden layer is known as deep learning system or deep neural network. So one is conventional artificial neural network, another one is deep neural network. In case of deep neural network, more than one hidden layer is there, right? So perceptron, as I said, intentionally kept one slide to make it understandable. See, this perceptron is the building block of neural network, and in the neural network, this perceptron is nothing but it is you can take it as a function only. In function, you can see more than one input. One is 1, one other is x1, another one is x2, and all the input are multiplied by their weight. Now, the input multiplied by their weight, but we are doing the summation of that, and basically this is the output. Directly we can supply the summation, that means the resultant value, or we can apply some sort of function over there, and finally give the output. Like it may be a step function, or it may be sigmoid or something like that. So this is the formal definition. Output is what? This is the nonlinear activation function. What is activation function? The result value of the main function, this perceptron, will be filtered out based on some nonlinear or linear activation function, which will be supplied to the next layer. So you can see this is weight. This is summation of the input and weight, and we are applying some nonlinear activation function on top of it, and we are getting the output. So that's all about the perceptron. Or the perceptron are somehow connected in every layer. So here you can see this X, that means all the inputs. Those are nothing but one column matrix, right? X1, X2, X3 up to Xm. Similarly, for each of the column matrix, we are giving some weightage, W1, W2 up to Wm. So two column matrices are there. We are basically making a summation of multiplication of those column matrix. So X, column matrix X transpose multiplied with the weight matrix. We are adding it with the bias. Now applying one nonlinear or linear activation function, we are getting the result. This is simple mathematics. One example will clarify this thing. In next slide, I will show you. This building block of deep neural network is like this. The previous thing, whatever I showed in my last slide, right? So effectively, what is that? X1, X2 transpose multiplied by 3 and minus 2, which is a predefined weightage. It will give you nothing but 1 plus 3x1 minus 2x2. What is that? It's a simply single one straight line like this, right? 1 plus 3x1 minus 2x2. And what kind of activation function we are applying? This is one popular activation function, ReLU, rectified linear unit. So you are simply supplying the output max of 0 or y. Whatever the value you are getting from that y, either that will be supplied or maximum or 0 will be supplied, depending on the value. That means basically you are supplying the positive value, whatever is coming out from your system itself. Negative value you are ignoring. So this is some sort of activation function. Different kind of activation function is there. Now let us see how this activation function, this perceptron, deep neural network is working to recognize a particular object, right? Without any predefined manual features. How? So say for example, this is one car. Whenever we are getting the image of one car, it will give me one matrix, right? Matrix of pixels, as I said. Now, if this is the input for on one predefined neural network, in that case, how it will work? See, different values will be activated in the first layer. Now, again, depending on that operation and that activation function, few of the values will be forwarded to the next layer and few of the nodes will be activated. Similarly to the next layer, and next layer. Finally, only one layer will be activated. That means where the probability is maximum. So effectively we'll get the result as car. That means you need not to identify whether wheels are there or not, whether steering is there or not, whether the size is rectangular or not. You need not to identify those kind of features. Simply you train your model with adequate number of sets, adequate number of images of that particular object, whatever you would like to identify, and pass it through your network. If there is any error, you try to correct the error. How you will correct the error? Simply you will readjust the weightage and the bias. Backpropagation kind of thing is there. So after adjusting all those weightage and all those bias, finally you will get one model which is one foolproof model. And using that foolproof model, easily you can give one image as an input and you will get the classification as an output. So this is the latest trend in image processing. Only image processing in conventional approach was there. Now on top of that, neural network and deep learning can be applied to get better performance. It is clear from this picture itself. For face recognition also, the similar kind of network is sufficient, right? And this network can be trained with your data to make it compatible with your system. Is it clear? So next one, feature extraction by deep neural network. One of the example, pictorial example. See, what is the concept? This is the image plane perceptron of deep neural network. Simply, this is nothing but perceptron of deep neural network, that is matrix multiplication, which was done earlier in the convolution part as well. So effectively, you will get something. This is nothing but feature map. In manual feature extraction also that was there, feature map extraction. And so basically it will give you first layer, edges, dark spot or something. So filter is there. Filter is nothing but here, that is the function you are applying through perceptron. And whatever you are getting, that is the feature map. And what is exactly happening in this neuron so that features are extracted from the raw images? Convolution, which is already explained to you. So the patch on the image is called filter or kernel. So in CNN, various filters are convolved through all over the image to trace out the features present in that raw image. And that is nothing but similar kind of thing. One particular layer may be responsible for identifying low-level features. Another one layer may be responsible for identifying mid-level features. Third one may be for high-level features. So on identification of low-level features, the valid values may be forwarded to the next level for mid-level features. Again, on valid identification of the mid-level features, that will be forwarded to the next layer for high-level features. And in this way, finally, you will get the complete set. Right? So this is the whole picture of convolution neural network. Input image. Now convolution for getting say, feature map, and then the max polling, and finally this fully connected layer you are getting, through which left portion is feature extraction and second portion is the classification. Effectively, it is nothing but it is just mimic of the human system. From human eyes, the images are coming to the brain. Different neurons, interconnected neurons, are doing some sort of operation on that image, and effectively you can classify that image based on your past experience or something. And if you have to take some action based on your recognition, you will do that. Similarly, computer also can do the same thing based on its training. And the speciality is you need not to simply identify the unique features of a particular object, or you have to preserve it for future reference in some data dictionary or something. It will automatically try to identify the unique features. It will automatically try to extract the features from the input image. It will automatically try to pass the valid values to the next layer, and effectively, finally, it will try to classify the objects based on the trained network only. Right. So that's all about the feature extraction and computer vision related activities. Now, simply I will give you one example where we applied similar kind of approach, and it is a success story only. But after that, we will move for steganography and steganalysis. If you have any doubt, still this slide, in that case, you can raise your hands and you can ask me any question. I will try to explain it once again based on my knowledge, right? So let you give me one example. Third eye. Third eye is one of the apparatus. It is for automatic capture. Hello. This is one apparatus for automatic capture of facial images of the intruder appearing in front of it and in unattended mode. The specialty of third eye is, in case of CCTV, it used to capture 24/7 videos, and that will be preserved separately for future reference. But the drawback is, in case of CCTV, you have to preserve the 24/7 video, so storage space requirement is huge, number one. Number two, if you really want to find out a particular incident from that, in that case, searching itself is very difficult. But ultimately, what is your intention? Most of the situation you used to put CCTV to capture abnormal situation. Like say, for example, your flat, you are not there in your flat, and it is in unattended mode. Something happened, something wrong happened. Somebody, did something wrong in your flat or in your any of your place of interest. So in that case, what will happen? Later, you will try to find out who visited that place at what point of time, right? So basic intention of the police people or the law enforcement agencies are nothing but to identify the human faces, the persons who visited that place with date and time stamp. So third eye is another one alternative which we developed at our end. There is nothing but one camera is integrated in a gadget, and it used to do facial detection all the time. Whenever any human face is appearing in front of it, so whenever any human face is appearing in front of the camera, it will automatically get activated. It will crop the facial image of that person, preserve it in a remote location, and the voiceover is there actually. Okay, fine. Well, so the specialty of third eye is it will capture the facial image of the intruder and preserve it in a remote location for future reference with date and timestamp. Already we applied for a patent and we got US patent as well as Indian patent for this one. This is a low cost development of the same solution, alternative of CCTV. It can be used for domestic purpose, and solution is pretty easy, solution is pretty easy. It is nothing but application of face detection in real time from the video itself, and other than that everything is mechanical arrangement. That means simply it will capture the facial image, crop the facial image, make a normalization, put the date and time stamp on it, and obviously the date and time stamp will be preserved in the image itself, which is nothing but hiding the date and time information within the image. So that's all about first part, image processing and computer vision. Now we'll move for steganography and steganolysis. Steganography, that is another one interesting area where one information can be hidden within any cover image. Cover may not be image only; it may be video, it may be something else. But basically, we are trying to explain it from image processing point of view. And our intention is not the steganography only. Steganography is the method for hiding information within a cover image, and the intention is to maintain the confidentiality, integrity, availability from this point of view. So our intention is the reverse one, that is the steganolysis. That means whenever we don't know the image appearing in front of us is consists of any hidden message or not, but our intention is to identify whether any confidential image is there, confidential message is there within the image or not, number one. If it is there, in that case, we'll try to extract that information, and the application, whatever we developed in the area of steganolysis, is intended for the law enforcement agencies, right? So this part of the session, Sonali will cover, but before that, if you have any doubt, you can raise your hands. Just hold for a moment. Let me see if there is somebody who is interested to ask any question from the participant. Any question from the participant? Any question from the audience?
Maybe we have a dedicated question in the session. That time they may raise questions.
Okay. So what we can do, we can proceed with this presentation first and later, right?
Yeah, you can.
So Sonali, I mean, should we? Are you going to share your screen or should I share it from here itself?
I am sharing. I am sharing from my end.
And you some noise is there, background noise is there. I don't know, exhaust fan or something.
Let me check.
Shrudeep, can you identify the source of the noise?
Sonali, you can switch
And
off
the
your-
noise is coming from Madam's microphone.
Yes.
Okay, let me check.
Sonali, fan. I think your fan or exhaust fan is something
Yeah,
is
fan. Maybe fan.
you switch it off.
How to he's wondering it.
Press switch on your AC here. Here your screen.
Is it visible?
Yeah, ma'am. You can go to presentation mode.
A lot of noise is there.
Yeah.
Just 1 minute.
Okay, fantastic. Now it is no noise. But she's off.
Microphone is off now, that's it.
Maybe you have to change the microphone. Again. Oh. Only thing you have to speak louder than your noise. Then you can hear.
Yeah. Is it now? This noise is still there?
No, we can hear you over the noise. Don't worry.
Okay.
We can hear.
Okay.
Because it may not be within your control to close the noise.
Yeah. Actually, my home is just beside main road. That's why.
Okay, no problem. You
Okay.
Carry on.
Yeah.
Please.
Yeah. Yeah, so steganography and steganalysis, as already sir introduced what about our activity in the area of steganography and steganalysis. So I am starting my lecture with the current scenario of steganography and steganalysis. Before that, I will introduce a bit information hiding and the real cases that happens and the reasons behind the information hiding and its vulnerability. Okay, so now in the current scenario, the rapid growth of internet usage and increasing practice of exchange of hidden information has created the burning threat in the area of cybercrime. As we all aware the fact that during the lockdown time, most people taking internet and internet basis service for doing daily work, communication, shopping, transaction, financial transaction. So result is that the internet services has been raises from 40% to 100% compared to pre-lockdown levels. Okay. The reason behind cybercrime practices lies the inherent vulnerability present in the redundancy of the digital data. So once upon a time, that information hiding steganography, it was academic research, but during past few years the academic research has been shifted to the application research and the delivery of the software which can attack or detect the cyber criminal activity in the area of information hiding, steganography, steganalysis, cryptography, cryptanalysis, all these things. So this is obviously the biggest concerned body is a law enforcement agency. So due to for information hiding, due to improvement in network activity, information hiding takes recently gaining an increasing attention from actors like cybercriminal, terrorist and state sponsored group, as they allow to store data or to cloak communication in a way that is not easily discoverable. Now, multiple methods of information hiding can be used by criminals to conceal incrementing data. There are many computer forensic tools, kits available specifically for cybercrime investigator that allows to detect multiple types of information hiding. Now, information hiding is a research domain that covers a wide spectrum of methods that are used to make secret data difficult to notice. There are several real-world cases that reached the attention of public media. So there are few cases, as we all know, Al Qaeda members in Berlin, they are with some video, they are hiding some information for ongoing and future terrorist operation in 2012. The German scientists, they have broken the things and revealed that part. The exfiltration of confidential data from US to Moscow by Russian spies in 2010. The transfer of child pornographic material by a group of pedophiles called Shadows Brotherhood, that happens in 2002. The planning of a terrorist attack after September 11, 2001 attack. A number of articles suggested that Al Qaeda members used steganography to coordinate their action in 2001. In all these cases, information hiding in any form, they use the information hiding for some unwanted activities. So these are the few information hiding technique, that is cryptography, covert writing, anonymous communication. Then covert writing has two different parts, steganography and robust copyright marking. Steganography has two types, linguistic steganography and technical steganography. Robust copyright marking, there are two different parts, fingerprinting and watermarking, etc. So now this is the statistics of what is the usage of the steganography on and information hiding. So graph already is showing the increasing usage of information hiding, different kind of information hiding. So here is two example. These are the two example. The left one is the original image and some information hidden into that left image and created a new image, that is right one. So apparently both of the images are same. So this is the steganography. Apparently the image or video, these are apparently same, but something is hidden into. So there are few real cases of steganography. Since March 4, 2022, 16 jihadis who belong to a sleeper cell of Al Qaeda have been nabbed by Assam police in massive crackdown on terror module. More than modus operandi, the operating style of the jihadi module is something that has raised the eyebrows of security agencies. During the investigation, police found that apart from using internal software for communication, the jihadis were also using steganography. A recent report points to the North Korean APT group named Lasers, who is considered to be responsible for the WannaCry ransomware outbreak. This is another case, seems to have hide payloads within BMP image files. The company Malwarebyte also reported this after they identified a document on April 13, 2021 used to target South Korea. So these are few cases. Also in US, some Japanese person who extract some business secret from GE. So I'm not going elaborate these real cases. So better I go to the steganography and steganalysis. So steganography is a branch of secret communication. Now this is a sentence, the normal sentence, since everyone can read. Encoding text in natural sentences is doubtfully effective. So first, if we extract the first letter from each of the word, it gives some meaningful word, that is secret inside. So this is a kind of steganography. So steganography is the art of hiding an information within another information in an innocuous way. The very existence of hidden message remains concealed. Now, cryptography is a process to convert the plain text message into ciphered text is equivalent to decipher it by the receiver. So, say Kolkata is a message. If we shift each letter from Kolkata, it gives that NRONDWD, but it may arise some suspicion. Say if there is a sentence, Kolkata is the city of joy, instead of that, if it is written like NRONDWD is city of joy, naturally some suspicion arises. But if we use steganography, there is no suspicion generated, as I already have already shown the image of Mona Lisa. One is tampered and another is non-tampered. That is, some secret information is hidden innocuously in one image, but it is not visible. And another is digital watermarking. It is just used for keeping copyright information. So steganography has a very old, age-old technique that from Greek, comes from the Greek root. Steganos is the covered, graphy or writing. So both is creating the covered writing. So first known usage is by the Greeks and Persians, used several forms of covered writing to conceal the communication of secret or covered message. Origins date back as far 2500 years ago. So this is the wax tablet. In Persia, they used to write some information in a wooden tablet, and it is filled by the wax, and then it is sent to to the desired location. So this is the steganography. Apparently it is very innocent, but something hidden into that. So this is another null cipher method. During World War I, Germans used to use this thing. So this is one example of null cipher. So uses of steganography is, one can embed information about photos in photos themselves. One can embed comments from radiologists in the background of a digitized X-ray. Hidden information can identify the legitimate owner of a document. If the document is leaked or distributed to unauthorized people, it can be tracked back to rightful owner. Steganography or preserving anonymity is also useful in political situation to avoid surveillance. Law enforcement agencies, police department can send secret information to peer communicator with the help of steganography. Now this is the actually good use of steganography. Now advantages of steganography. The steganography is for protecting data, such as in the field of media where copywriting ensures the authentication. The steganography can be used by the intelligence agencies for transmitting their secret information. Nowadays, the medical image they are also protecting using the steganography method. This is very upcoming area of application right now. Disadvantage of steganography: by using steganography mechanism, many terrorist and have anti-humanist activities have occurred. Now this is a schematic diagram. The first one, 1A, is the original image, that is cover image, and second one is a tampered one. In bare eye, nothing can be shown. Now let me analyze this thing. First, I am putting the LSBs into, I am plotting the LSBs. This is 1B, and corresponding for the 2A is 2B. Now for the original image, there is nothing hidden into LSBs, but for 2B some information is hidden when I am projecting the LSBs. So unless and until deep analysis, one cannot detect whether anything is hidden into a image or a file or not. So deep analysis is required. Now steganalysis is that deep analysis. So steganalysis is the practice of defeating the goal of steganography by detecting, extracting the tampered bits and reconstructing the hidden message. The role of steganalysis is to inspect suspect packages, determine whether or not they have a payload of encoded information into them, and if possible recover the payload. Now this is the deployment scenario of steganography. User 1 is creating a steganography object using some cover image or cover file by using a key and a message with the help of a steganography encoder. And using that encoder, stego object is being created, and over internet it sent to user 2, that is his or her peer communicator. Now user 2 has the detection, has the steganography decoder, and also in some channel he or she has been received the key by which user 1 is creating the stego object. Using that key and decoder, he or she can able to extract the hidden information. But in between the communication from user 1 and user 2, suspected if law enforcement agency suspects something, they can eavesdrop in between, and here lies the role of steganalist. Steganalist tries to detect whether anything is hidden or not. If anything hidden into that one, then he or she tries to extract and reconstruct the message. Now the message can be any kind of multimedia object, cover can be any kind of multimedia object, and stego key is unknown like password. Now difficulties for steganalist. Now steganalist does not know any prior knowledge of the steganography encoder. Even when any file received by steganographer, he don't have any cover or any steganography encoder in his hand. So this is a kind of blind analysis. So there are three different kind of steganography: pure steganography, secret key steganography, and public key steganography. Hello, am I audible?
Yeah. Yes, madam, you are able. Madam, you are audible.
Microphone is off now.
Your microphone is off.
Yeah, just 1 minute, sir.
Oh,
Yeah. As the pure cryptography, pure steganography does not require the prior exchange of some secret information like stego key. Both sender and receiver must have access to the embedding, mapping, and detecting and extracting algorithms, but the algorithms should not be public. Now the secret key steganography, it is similar to symmetric cipher. The embedding is done using secret key. The secret key must be communicated through a secure channel. Public key steganography, it is similar to public key cryptography system. The way to build a public key steganography system is to use of public key crypto system. If the natural randomness of any cover is statistically indistinguishable from ciphertext produced by some public key crypto system, a secure steganography system can be built by embedding ciphertext instead of an unencrypted secret message. A protocol which allows public key steganography has been proposed by Anderson. So, as I already told, the different type of cover can be used during steganography. So still images, video images, audio and text, this any kind of cover images cover file can be applied to for steganography. Now Now message also, it can be as I told, it can be of any type of multimedia objects, and size can be varies from 1 letter to bytes, I mean multiple bytes or kilobytes of message can be hidden depending upon the size of the cover file. But the amount has some limit, because if we doesn't consider the amount of the message size, some distortion may arise into the cover. So there are different techniques for steganography, that is substitution system, transform domain system, spread spectrum, statistical method, distortion technique, cover generation, etc. So substitution system substitutes the bits, that is the redundant, not only bits, not only any bits. The substitution system substitute redundant part of a cover with a secret message. And most of the steganography tools, they are uses substitution system to create stego files. Transform domain techniques embed secret information in the frequency space of the signal. Spread spectrum technique adopt ideas from spread spectrum communication. Statistical methods encode information by changing several statistical properties of a cover and use hypothesis testing. Distortion techniques store information by signal distortion and measures the deviation from the original cover while decoding. Cover for communication is created according to the statistical parameter of message. Now, during steganalysis, as Ritesh sir already told, we have two different products which are copyrighted. So this has three different levels. First one is detection. As I already mentioned, that detection is a major event for steganalysis, because we are doing blind steganalysis. So first one is detection, whether anything is hidden into the input file or not. If anything hidden, then we try to extract the probable corrupted bit or streams, and if possible from the extracted bit we try to reconstruct the message. So disabling of hidden message by performing some transformation like translation or rotation or scaling can be done, but our law enforcement agencies requirement is to maximal reconstruction of message. That is very easy for their investigation. So there are several disabling technique of hidden information. So disabling capacity depends on the payload, that is data hiding capacity. In 24-bit BMP images, huge data can be hidden in LSBs, and data can be simply disabled by averaging, scaling, translation, rotation, etc. So in JPEG compressed image, message is encoded in significant information of image payload is less than, in this case, effect of distorting the message may distort the image itself. Successive decompression and compression of the image can be disabled by the message. Now there are several parallel attacks available for the steganalyst. Stego only attack, known message attack, chosen stego attack, chosen message attack, known stego attack. So the definition comes out from the name of the attacks itself, but in real life the steganalyst has to done the blind attack, that is unknown cover, everything is blind. Okay, so the steganography tools, they are different. Each and every steganography tools, they are different in many means. So first one, they use some cover, this use some message, they use some key. Then by using stego tool, some stego tool use non-encrypted message, some uses encrypted message. That means the message, it as it is used to be hidden into the cover file, that is non-encrypted. some stego tools use some encryption logic and created some ciphertext, then only they hides that ciphertext into the cover file. So depending upon the hidden hiding technique, the criticality of detection become increased. Now some tools, they are using serial distribution in the cover file, and some of them are uses random distribution. So depending upon the hidden message hiding technique, the criticality of detection increases. Now there are different levels of steganalysis. Detection can be done in several ways. Statistical detection, then extraction of probable corrupted bit stream from different format from image or audio data, and reconstruction of message can be non-crypto, weak crypto and robust crypto. So as I already mentioned, there are random embedding and serial embedding and random embedding, cryptography, use of cryptography and without use of cryptography. Depending upon these, the steganography tools can be divided into 6 different levels, and this is with varying critical. The criticality varies from level 1 to level 6. For example, non-crypto and serial embedding, this is very easy to detect, extract and reconstruct, whereas strong crypto and random embedding, this is very difficult to detect. So in our CDAC Kolkata, we have developed one steganalysis software, and we are able to generate 89 different steganalysis modules, and this 89 steganalysis module has been developed according to this criticality. So these are few examples of steganography software, this and with different levels of criticality. These are some commercially available tools, steganography tools. So there are different encoding techniques, LSB substitution pair of values, checking blockiness in JPEG images. These are different techniques. So now this is showing the, as Ritesh sir told, that image processing. Now image processing is image format is very much required for steganalysis. So here we are placing the different bits. We are plotting different bits of a image and showing what it comes. So this one is, first one is the original image. We are plotting LSB, next to LSB, and so on up to MSB. Okay, so we can here easily we can see that LSB is carrying the least amount of information. So LSB and original image is almost same, but for MSB we can see that the initial few bits from the sky is showing some different colors. That means this portion is being tampered, and MSB is carrying the maximum information. That's why the tampering is done, and it is very easily detectable. So the substitution method also always use the LSB. So as I told, visual impacts is evident in case of MSB on tampering. Now this is again, we can see that LSB is the most random one, and MSB is carrying the maximum information. Now, in 24-bit BMP, there are 3 different channels: red, green, and blue. So, information encoding in the most significant part of the cover. So, in case of red, green, or blue, the tools used to hide in the 0th position in any channel. Similarly, in palette image, the information hiding takes place in the red, green, and blue channels of the color palette. So, as I told that the LSB pattern, the LSB is most random in any images. So, the first one is the covered image, and second image is the image after hiding. Now, for steganography, the randomness of the image used to increase due to adding the information, adding the hidden image, hidden message. Sorry. So, if we plot the LSBs of the original and after the LSBs after hiding, we can see the randomness of LSBs increased in the tampered image. So, measuring the randomness, the difference of randomness, we can see, we can create the feature of the tampered image. So, this is some kind of statistical analysis, chi-square test we used to do. So, before embedding the LSB, if we plot the LSB before embedding it, this is 4 1, then 2 zeros, then 3 1, then 7 zeros, 3 1, then 8 zeros. But after embedding, we can see 0 1 1, 0 1 1, 0 0 0. So, the 1 and 0 jumbled up so much. Here, we are creating a large database, and we first try to extract the feature with known cover, known message attack, and try to detect the feature of the tampered and non-tampered image. And depending on these features, we try to classify the original image and tampered image. So, this is the bitplane data for LSB substitution. The first one is 200. This is the original data. So, first one is 200. It changes to 201. So, LSB is being changed. Second one is 176. This is got changed to 177. Like this. For palette based image, this is a new set of algorithm. This can be done for 8-bit image, GIF image, etc. They use properties of the palette used by 8-bit BMP and GIF images. They can detect even a single alphabet inserted in the image. So, in case of palette images, one palette is kept separately and the image data points to the color palette. So, when color palette got changed, the image is being changed, and the color randomness of the color palette increased during the steganography. So, color palette sorting, if we do the color palette sorting, then we can get some measure of steganography. So, this is the result. The original image and the tampered image, we can detect that there is some kind of color palette sorting has done for the tampered one. Now for 24-bit BMP, that close color pair signature is very poor. So we can't do anything in the close color pair and close color pair analysis. This is a kind of statistical analysis. This is not giving very good result for 24-bit BMP images. Now in statistical steganalysis, there is a drawback that if the payload or the amount of hidden information is not very high, then the statistical measure doesn't give very good result. At least 30 to 40% payload is required for getting a good result for statistical steganalysis. Moreover, the statistical steganalysis only for detection. Okay, so it is not giving the confirmatory, it is just giving confirmatory test, but our law enforcement agency need the extracted message. So that's why CDAC Kolkata is concentrated more in the area of signature based analysis. Now what is signature based analysis? I am showing this one. These all are the result for statistical analysis. I am skipping this one. So this is the bit plane of a GIF image. If we study the GIF image file format, that 003B is the end of file marker for GIF image. The first one is the untampered bit plane of untampered GIF images, that it is pointing to the end of file marker. Same image is tampered with some message and it is showing that 003B after end of file some information is hidden. Okay, so this information is nothing but the ASCII of Kolkata. Afterwards C, Kolkata C. So we are used to do noun cover known message attack for a large database and trying to find out the inherent technology that the third party tool used to do. This is called signature based analysis. For this particular tool, that is PGE, that is embed text data at the end of GIF file and keeps the data serially. So this is after 3B, it is showing that for any image tampered by PGE, it is showing the Kolkata C message after 003B. Similarly, this is another tool. It's called Secure Engine. This is a public domain steganography tool. We extracted the nature, the behavior of this particular tool. This acts on JPEG image and embed the text data serially after the end of image marker. Now what is the end of image marker for JPEG? It is FFD9. So after FFD9, it is showing that it is hiding some data. After FFD9, it used to add 20 hashes. Okay, after that it hides the text file name and the message. So like this, we can able to extract the data with after detecting the signatures. Now for that particular case, after end of file, 20 numbers of hash, this is the signature. So depending upon this signature, we are trying to detect the name of the tool, and afterward we trying to extract the tampered bits and then the tampered message also. So that is the example, that is the end of my PowerPoint presentation. Now I can show you one example of steganography. I think it will create some interest in you. So So this is I'm showing you some images from our created database. Oh, it's very small. Let me check. Yeah. So this is the tampered image. Now I am opening the original image, I mean covered image.
Madam,
Yeah.
only it is a PowerPoint slide it is shown. It's not coming.
It's
your
not
image.
coming? Okay, okay,
No.
just 1 minute, okay. Just 1 minute.
Share your entire screen.
Is it visible?
Yeah.
Okay. So this one is that one tampered image. Just 1 minute. Is it visible? It's very small image. So, is it visible? Hello.
Yeah, yeah.
Yeah. It is a very small image. I am trying to show you both the images, tampered and non-tampered side by side. This is a database image that we have a large database of steganography, like almost 1 lakh or something like that. So the left one is the original image, okay, and the right one is the tampered image with some third party tool. So see, both of them are almost same, are totally same, almost in bare eye you can't see anything, okay. So if I can show you our software, what it gives you. Is it visible? Yeah, this is our software that we have developed. This is a SIDAC Kolkata zone software, Stego Check. This is a steganalysis software. This used to detect whether anything hidden in the input file or not, okay. So here I am selecting the image that I have shown you. So this one. So by clicking the steganalysis, it starts working. First, it detects whether anything is hidden into that file or not using the search. It has 89 different signature bank for 89 different steganography tool. Using that signature, it tries to find whether any signature is within the input file or not. Depending upon that, it detects true and tries to detect the name of the tool, name of the third party tool by which the tampering has done. Here the tool name is camouflage. Now this particular software camouflage uses some password. Now since it is a very low level encryption, it uses very low level encryption, so we can able to extract the password name also. Okay, so so after that it extract some unicoded message, some Hindi and English mix message we can able to extract. So there is a generate report facility is also there. One HTML report can be generated. So this is the detection, extraction and reconstruction of message. For some it is now it is 89 different signature based steganalisis module is there, and for strongly encrypted tools, that is also can be done, but GPU is required for this because password cracking kind of thing is already included into our this software. So this is a glimpse of one software, StegoCheck, along with us. The another software is a stego forensic kind of thing. That is, for example, if you your machine, if you use some steganography tool for hiding or tampering data, some imprint is present in your machine, in your registry or in your file system. That our another tool, it tries to find out the signature of that particular, the forensic signature or the artifacts in your machine or registry. Okay, so this is our another tool. So both of the tools are copyright protected. Indian copyright is there. So that's all about my presentation and demonstration in the area of steganography and stegananalysis we have developed so far. So is there any question?
We'll take the questions just after some time.
Okay.
So thank you, madam, for giving, and thank you, Mr. Mukherjee, for giving the excellent presentation on image processing information hiding using steganography as a case study. As we have seen that we are utilizing the artificial intelligence and machine learning in every sphere of life, and this image processing is of no exception. We have seen that in the traditionally in the machine learning models, there is a process called feature extraction. And for the complex problems such as the object recognition or handwriting recognition, there is a big challenge because of the dimensionality problems, as well as to focus on the right features on themselves and to handle the huge volume of data. We have seen that deep learning is the only alternative, and we have seen that it is the idea is behind the deep learning is to build the learning algorithm that mimics the human brain. As it has been told very clearly that in our session, that whenever we are doing the computer vision, the human vision, the way the human sees the object and analyzes it, exactly mimicking has been done by applying the deep learning model, where the lot of neurons, the artificial neurons, which are known as the perceptrons, are mimicking the human brain of any neural cell is consisting of, that the dendrons as well as the axons. So dendrons take the inputs, and it is processed in the nucleus, and then the information is passed via axon to the next dendrons. So similarly, the information is passed from the one neuron to another neuron, and here the neuron is made as a layers. So you have seen in the computer vision, since the machine is recognizing the objects or the images as a number, so what it happens is that it will be taking the colored images as the R, G, and WB images. So it is a three-dimensional case. And three-dimensional case, it's not a matrix. So it's a tensor. So different type of analysis is required to be implemented here. And the tensor analysis is being done in the system. And for the computer vision, the different features are getting extracted. And after doing the extraction, the classification is done based on the different algorithms, and the item, that is the leveling of which is coming with the highest probability, is detected as a particular object. So that we have seen with the multiple images and algorithms. Now, what we have seen that in the neural network, it are the different layers are there. So there will be some input layers, there will be some hidden layers, and there will be output layers. Each layer is having some particular activity. Like the input layer is taking the input from the object, and then it is passed through the different layers, which are the hidden layers. So it will be doing particular activities like the low-level features extraction, mid-level feature extraction, high-level feature extraction, which is taking the edges of dark spots or eyes, ears, nose, or facial structures like that. And then some particular output layer will be lit up and to see which particular image it is of. So by this, it is getting extracted. And if we see that the image, whenever it is getting analyzed, so it is getting analyzed automatically from the data. So there is no given filter or like that. It will be just doing like this. So the initial input are getting extracted, that is the filters are coming out as kernel, and it is passed to the different pooling layers, the convolution and ReLU layers. It is a series of layers. After that, it is basically doing the feature extractions. After that, the entire layer is getting flattened and passed through the fully connected layer, but the classification algorithm is run. Now, in the deep learning mechanism, what is happening from the left to right, when it moves, it does the forward propagation. Now, in the forward propagation, what it does is that it is identifying something. And after that, it does the backward propagation, because it is comparing with the output, whatever it is desiring for, and then the backward propagation happens. In the backward propagation, hyperparameter tuning is done, that is the weights, bias, and all the parameters are getting adjusted automatically to come out. And this will be done in a loop till the final output is getting achieved. And if you are getting the different levels are there, more than 2. So it will be the algorithm will be the softmax activation function, as for example, which can give the probabilistic distribution function. The thing which is with the highest probability will be getting detected. So it comes as an output. So this is the way the object is getting detected via the different layers. And we have given some third eye is an example, which basically is suitable for surveillance of individual houses, apartments, housing complex, bank ATMs, hotels, guest house, and similar type of activities. And we have seen a practical example as the steganography. And then the steganography, it has been seen, it is basically the information hiding. So information hiding is a lot of cases have been shown over here, and the cases are getting increased. And we have seen that the actually, whenever the image is getting passed, you cannot find out what is the basically the actual image and what is the basically the tampered image. Basically, some rules and some stochastic rules and those things are put over there to find out. So steganography is a branch of a secret communication. So it is basically art of hiding an information with another information in innocuous way, and the very existence of the hidden message remains concealed. So that's a matter of concern. And it has been seen that it has come with the Greek roots, which makes the covered writing. So it is of the old usage, but now it is coming with the modern flavors. Now it has been found that it can be having the advantages also that you can use for the protecting of the data, such as in the field of media, where the copywriting ensures the authentication. And it can be also used by the intelligence agencies for transmitting their secret informations. But as with the different technologies, the pitfall is always there. So it can be utilized by the terrorists and have the anti-humanist activities, which will be a dangerous one. So steganalysis has come, and they are having the different kind of the protocols in the steganography, like the pure steganography. There can be a secret key steganography or the public key steganography. And for that, the different type of tools have been prepared in case of steganalysis, which takes does the detection, extraction of probable corruption bits or bit streams, and reconstruction of the images. As you know that whenever the legal interception teams for the different the agencies, law enforcing agencies, they are getting the inputs from the operators. So the operators have to put the legal interception systems, and they are having the parallelly fanning out of the data. As there are 8 agencies, legal enforcement agencies at this moment, there can be more. So the 8 systems can be fanned out maximum, and the way they want it can be done. So it can be provisioned by them, and the extraction, the data will be going as a secret VPN in the system, and it will be going to straightway to them and enabled to them only. It cannot be tampered by anybody. And the proper tools and the systems can be implemented by them at their end to take out the exact data. So there are the different types of the criticalities, and the different type of engines are already there to take care of that, which have already been discussed with you, and the different kind of mechanisms have been told by them. How the tool substitution systems and bitplane, there are the different tools for the substitution systems, specifically in LSB, where hardly people can distinguish the original and the tempered picture by naked eye. So there are the statistical steganalysis. There can be the chi-square test, which can be finding out the tempered image and the amount of randomness which have been generated. And there are the different other methods also, the different methods they have adopted, and they have implemented a stegocheck tools, which is a basically steganalysis software. And what they are doing, they have developed the 89 steganography tools, which the signatures, which can be are there, which can be detected by this system. So that is a very good, because it's first of all made in India, and it is we are proud as an India that the software engineers, the young and talented engineers, they have taken the challenge of this type of attacks and others, and it detects which particular tool has been used, which particular password, and what is the exact message, because the legal interception system want this. So that's a very good thing. Thank you, both the speakers in this panel, and it's really a very good discussion, And really, it is a need of the hour where you have come out with the appropriate solution in this forum. And I think the entire audience, they have been enlightened with these things, and you have come all the way to give this presentation on the webinar front. And once again, we extend our sincere thanks from Institution of Engineers, Electronics Telecommunication Division. So now I ask the audience if you are having any question to ask to our panelist. Mr. Shashwata Shah has asked one question. I have previously done the same task of getting out the strings of data embedded using Linux terminal in an image. I could find what strings are in it. I wanted to know how this application is working and would want to know how it is detecting which application has tampered with the data.
So 2 points is here. I mean, Sonali will answer the question, but before that, let me explain 2 things. Number one, as Shashwata Saha mentioned, he did some sort of data embedding using Linux terminal. Basically, Linux terminal Windows is not playing any role on it. So if the steganography tool is made for Linux, in that case, you can make use of it in Linux environment. If it is available for Windows, in that case, you can go for Windows. So bottom line is basically you are hiding one message in an image, and later you are trying to find out what is the image actually there. So if the message is already encrypted using some encryption algorithm, so in that case you may not be able to extract the exact image depending on the, level of complexity on that encryption technique itself. But at least you will be able to understand whether there is any message embedded in the image or not. That is one issue. And second thing is, if it is embedded, so there will be some sort of signature. Every steganographic tool has its own signature, how it will put the messages on different part of the image or covering whatever may be covering object. So basically, based on that, you can at least trace out what tool was used for embedding that message in the cover image. I think that is the answer. But Sonali is expert in this area, so Sonali can obviously add some point on it.
Yeah. Actually, if the signature, there may have some signature, direct signature, maybe indirect signature. You have to analyze that first. If there is signature, then it is very easy to detect. In some cases, no signature is there. This is very difficult actually. So for if it is false in level 6 that I have already mentioned, that is random embedding as well as strong encryption before embedding. In that case, it's very difficult. So in that case, you need to study very deeply, like first known cover known message attack. Using known cover known message attacks, you have to first find out whether any signature, there is any signature or not. If not, you can go for any deep learning based technique that can be applied for detection only. But for extraction, you have to go extraction and reconstruction, you have to go some signature based or some brute force technique. For example, we have developed one tool where there is no signature, and the hiding of message is time. They're using some time dependent random key. So time t1, the position got changed when it is tampered at time 2. For this, some brute force kind of thing, specific brute force type of things, that is some kind of feature augmentation is required for this analysis. That's it.
Right. So I'm asking the audience, is there some other questions you want to ask Mr. Daipan Ghosh, Gayatri, Isranil, Kalavani, Sunil and Sapnil? Do you have any other questions? So we can, our experts are here, they can answer you.
With your permission, I would like to add one point. Actually,
yeah,
Conchal sir already explained everything nicely. Only in one point I would like to add, as you said ReLU as a layer, but actually ReLU is not the layer. Better to say it's basically activation function.
Yeah,
in
it is
any of
basically convolution and the ReLU. So it's there as an activation function in that
Yes,
individual
yes,
layers.
absolutely, absolutely. So basically, activation function is what? Whenever we are getting some output from the perceptron, activation function is taking that output and trying to understand whether that will be forwarded to the next layer or not. If it is to be forwarded to the next layer, in that case, in which shape it will be forwarded. So it's a nonlinear function. ReLU is one of the popular activation function. So in most of the cases, it is used for taking the decision. Otherwise,
Yeah.
some alternatives are there also. Like one is escape function, another one is your sigmoid. These are also
Yeah,
popular.
sigmoid is also used.
Yeah, sigmoid and escape function is also used in some cases.
Yeah.
But true
Yes,
false
yes.
is important, right?
Absolutely.
Yeah. So that is my submission from this side.
Yeah, yeah. Activation function, just like as a part of that, I told the class. So it is a basically activation function.
Correct. Correct.
Yeah, yeah, yeah. So any question from the participants? Else, we can give the vote of thanks, Ramda.
Yeah. I think we have not much attendance today, but it's a very, very difficult topic to understand and highly mathematical. Okay, but our experts made every attempt to make it as simple as possible in layman's language. My heartfelt thanks goes to Mr. Ritesh Mukherjee and Madam Sonalida and Dhali Mustafi for elaborating such a difficult topic in such a lucid manner. Thank you very much for your valuable time spent with us. And I really am very happy to have more attendance. Okay, this is not in our hand. Around more than 100 people registered for the session, but only around 19, 20 people could participate. Okay, thank you very much. Thanks giving the customer for our secretary. I don't see he is present here today. So I take the responsibility to propose vote of thanks to the experts, to our dear moderator, Chanchal, and all the audience, and over and above, Steve Chakraborty, who is with us, Institute of Engineers, to conduct this session. Thank you very much. Have a pleasant evening. Thank you.
Thank you, Ramda. And thanks once again to our panelists, Mr. Ritesh Mukherjee and Madam Sonali Dhali Mustafi. So wish you now, we can close and wish you the very good evening to you, all of you.
Yeah,
happy
thank
evening
you.
and
Thank
happy
you.
weekend also.
Oh, thank you. Happy weekend. Sudeep, kindly
Thank
close
you.
the session. Thank you very much for the kind help and support.
Thank you,
Thank you, sir.
Thank you.
Thank you, ma'am.
Thank you.